everyone. Welcome to AI for Developers. Thank you so much for joining us. My name is Sinead. I really appreciate you being here. Today we have a great lineup. We have 4 different speakers, so I'm going to get started. Just a couple of announcements for me. Our co-organizer today is N8N. I'm not going to tell you too much about them, but Max here is going to tell you lots and show you a demo about how you can kind of supercharge your automation with AI. Our lineup, as I've said, we have Max, then we'll be hearing from Apoorv with empowering agents with LLMs, how to cut your agent dev time by Filip, and then finally from Daniel, we'll be hearing about unit testing LLM-based features for full stack engineers. Great. Doors close at about 10 minutes to 9, so hopefully you'll get some time for some pizza and networking before then. I'm always on the lookout for speakers, so if you or somebody you know would like to speak and you're using AI in your professional day-to-day, I would love to hear about it. You can reach out to me. Our next event for developers is on August 21st, but we have lots of different speaking slots throughout the year, so do let me know. Great, so without further ado, I'm going to pass it over to Max to get started.
Hi everyone, how's it going? I'm Max. I just flew in this week from Berlin to give this demo. I'm very excited to be here, first time in SF. And I'm here representing N8N today. I joined N8N about 4 years ago as our first founding designer. And last week I transitioned into DevRel, so this is my very first demo. And I'm really excited to show you a lot of the AI functionality we've been working on in our workflow automation product. So my talk is on supercharging automated workflows with AI, and I promise you I don't have a single slide to show you other than this one. We're going to stay in the product the whole time. We're going to build. We're going to show you what N8N's all about. So N8N, okay. So yeah, supercharging automated workflows with AI. So what is N8N? N8N is a low-code automation platform for technical teams. There's a lot of workflow automation products on the market, right? But I think what differentiates us, it's not a single feature. It's really about who we're designed for. So we're designed for people who know how to code. You don't have to be an expert to have, get value from the product. But we really give you the options and all the settings and all the things that you expect when you're working with code. So to give you a really simple example here, there's steps on a canvas. Each step executes, it outputs data and passes that along to the next step, right? So this really simple example, if I open up my webhook trigger and copy the test URL, if I test this workflow and I open up, let's say, a new tab, and let's say we pass along a URL parameter, we see the workflow executed, right? So if I double click my webhook trigger, and I pop over to schema view here, we can see I have access to all the raw data that came in from that webhook. Maybe that's useful, maybe it's not, but it's for you to decide. In this case, it's this email variable here that I need to access in my if node. I drag and drop it, I set up a condition, I have all the various things I might expect to work with, like data types and whatnot, right? We call things a Boolean because that's what it is. And we see here this routed out to the true branch. We executed some arbitrary JavaScript. We added something to Postgres. And if this wasn't the case, if the email had not been at N8N or hadn't included N8N, we might send a Slack message. So to give you an example, we have hundreds of different apps that we connect with natively, and we have generic connectors, right, for HTTP requests, FTP, all the various protocols that you might need to connect to. So you might be asking me, Max, I don't see any AI here, right? So this is what N8N has been doing for about the last 4 years, is providing a workflow automation product. And now we've added an abstraction of LangChain to allow you to build far more sophisticated AI workflows. And I think for us, what we're realizing and seeing is that by adding AI to a traditional workflow automation product, there's a lot more use cases that become feasible. And we have a lot of maturity in a lot of the things that maybe some of our competitors might not have yet, since they started off as an AI native tool. So in the first example, let's build an automation that categorizes emails coming into this inbox based on 2 labels, either automation or music. So the first step I'll do is we need to start this workflow when I get something in my Gmail inbox, right? So I'll go to Gmail here, and we'll add a trigger event when a message is received. Okay, so I already have a credential set up in here. If I need to create a new one, I could. This is a poll-based trigger. Many of our triggers are event-based. This one's poll-based, so we handle all the deduplication under the hood. And in this case, I don't want to simplify the output. So let's fetch a test event. This is going to bring in the latest email. Again, I'm seeing all the raw data that I'm getting from the Gmail API. If I collapse this, I can see I have the email itself here. So this is what we want to analyze and classify. So in the next step, what we're going to use is one of our brand new text classifier nodes. And this is one of our advanced AI nodes. So this is an abstraction on LangChain. So like in LangChain, I have various dependencies I might need to connect to this. But before I do that, let's set up the parent node itself. So there's various parameters to fill out here. There's the text to classify. For this, I'm going to go ahead and drag and drop the text. And we can see we've created an expression in N8N. And we can see there's the result of that item coming in there. What I might want to do as well is also pipe in the subject. Maybe that's useful context. So we can do that as well. And now we've got the subject and the title. I could, of course, if I need to, apply various methods to it. We have helper functions, but also plain JavaScript. But in this case, I don't need to do any of that. So the next step would be to define the categories that I want to classify by, right? So for the first one, I want to do automation. For the prompt itself, let's just copy paste that so you don't have to see me awkwardly typing that out. So what we see here is a very simple description, right? Nothing too complicated. We'll do the same for music. And I'll paste that in as well. Okay, and if I wanted to, again, N8N has a lot of options for you. We progressively disclose those if you need them, but if I needed to also maybe have a different output when we don't know what's happening, I could do that as well. And now we see we've created all these different output branches. So the dependency here is a model. As you can see, with various different models that we support here. This list is growing every day, self-hosted models, etc. N8N is also fully self-hostable. We have users running on a Raspberry Pi. We have users running in the cloud. So you could totally run everything you're seeing here today on-prem if that's important for you. So in this case, I'll use ChatGPT or an OpenAI model. Since it's a demo, let's go with the brightest and best for now. And again, there's lots of options here, right? So maybe I'm an enterprise and I have my own cluster. I can easily change the base URL there. Maybe let's turn down the sampling temperature a little bit. Okay, so let's see if this works. Let's run that. And we got something coming out, the automation branch here. This email is about automation. We'll do a test afterwards, so you can check me on that. And then this last step, I just need to add a Gmail step. We want to add the automation label. Move that here. And then for the message ID, we're feeding in data from before in my workflow. Again, here. We'll duplicate this. For the music step, we'll change this to music. And so now, this workflow, if I check my inbox here, let's send a new email. Send that. Okay, so this is about music, right? It's about a disco edit. Let's clear this. Let's run the workflow. And we're just going to stop this real quick. And we're going to pause this trigger here. And then if I run it again, it's pulling in the latest test event. Now again, once I activate this workflow, this would work automatically. And we see this was routed to the music branch. And we apply the music label. So that's text classification in a few minutes. Now I have a RAG example as well. I'm looking at the clock. We got about 2 minutes left. So I'm going to run through this really quick because there's a really cool thing I want to show you in a little bit here. But basically, with this example, I've got the BTC white paper. We're going to run this. This is handling text embeddings and inserting this into Pinecone as a vector. Those are in Pinecone now. Again, showing traditional steps like downloading a file with the AI capabilities. And then in this part, with our chat trigger, if I ask what is the first reference in the Bitcoin white paper, it's going to answer this. Now, what when did the ETH white paper come out? This is something that GPT-4 would know, right? Most likely. Ours doesn't, because we have guardrails set up that we want it to just use the vector store itself, which is important when you're building something for a production environment where you want to control the results, right? So that's something that NNN helps you do. So in the last 60 seconds, I'm going to show you our brand new feature, which allows our AI agents to interact with tools. And the tool that we've added now is the ability to teach your agent to interact with any arbitrary REST endpoint and define the parameters that it can control with placeholders and the things that it cannot control. Again, guardrails. So if I run this, let's say, can I make an appointment for this Friday? Let's see, certainly this Friday would be this. To proceed, I'll need the following information. Okay, when is Max available? Let's see. In this case, I'm using an Anthropic model, but again, you could swap that out under the hood. So we have the availability times. Let's see, can I book an appointment for 9 a.m.? Now, I haven't given the full name and email address yet. Agent's handling this all under the hood. So my name is Nathan Automator, and my email is nathanautomator@gmail.com. And now, so we use the first tool, which was to check the availability, and now this second tool is consuming the endpoint to create an event. And so we book that. If I check in my calendar, we can see that we've booked a meeting between Nathan and Max, right there. So in short, this is a very simple example, right? But you have multiple various tools that this agent could use. And just to give you an idea, this is just one of the tools, right? There's off-the-shelf ones, or you can even call an NNN sub-workflow. So hundreds of integrations that we have, you can start having your agent interact with those as well, be it something that's off the shelf like a SaaS tool, or something proprietary that's on your own local infrastructure. We're at time now. Thank you very much for looking at this demo. It was just a sneak peek. Afterwards, of course, I'll be happy to show in a bit more detail. And feel free to connect with me online. And if you do save this link, by tomorrow I plan to upload this template as well, so you can download this self-hosted on our cloud product and play around with these demos yourself. Thanks, everyone.
I'll just check, is there any questions? Would anybody like to ask Max anything while he's here? Yeah, great. If you'd stand up for me so LinkedIn Live can see you as well.
Yeah, hi. Great talk, very helpful, thank you. So in Gmail, when it applied the label music, you didn't use any filters in Gmail, right? So how did you make Gmail, like, was that some connection using API to apply that label, or what happened there?
Sure, so what's happening in this example, right? This is the AI step. This is what's handling my fuzzy semantic language. This step here and this step here are things that we've had in NNN for a couple years, and this is a standard action. So as you can see here, this is the Gmail node, as we call it in NNN. It's operating on the message resource. The operation is add label, and exactly, under the hood, we're interacting with the Gmail API as abstraction for you. Now, let's say we didn't have Gmail, or let's say we didn't have your proprietary app. You could do the same thing with an HTTP request node, or an SFTP node, or any sort of protocol that you need to interact with. SSE events, etc. Yep.
Awesome, brilliant. Anybody else? Yeah, great. Brilliant. There you go. Let me turn that on for you.
Hi, my name is Ravi. And do you have an option like a prompt-based designing this workflow rather than just drag and drop? We can write a prompt and it can make this workflow.
Sure, so Gen AI of workflows themselves is on our roadmap. one of the squads that I'm actually involved with right now is working on an AI assistant. That's not going to be the very first task that we launch with. Okay. To be honest, we did some POCs on handling that, and we saw a lot more value from helping users solve the errors that they're doing in building their workflows. But that is something on our roadmap. Most likely, it won't be a type of single prompt and build out a whole workflow. We see that with some of our competitors, and we've tested it, and I think the results for many users are a bit suboptimal right now. So when we approach that, I think where we're going to explore is probably step by step, describing the next step in the workflow. Okay. But yeah, that's on our roadmap.
Okay, yeah, thank you.
No worries.
Excellent. Anybody else? Let me get you a mic so we can hear you.
The workflow builder that you're using here, is it proprietary? Have you custom built it, or you're using some?
Yeah, so the app that you're seeing right now, this is N8N. So this is our workflow automation tool. It's source available, so you can self-host it, you can fork it, you can tweak it, etc. Yeah.
Hi, thank you so much for the talk. I'm using text classifier. What kind of text classifier are you using? I'm using Vertex AI and CoML, and I wanted to know, is your own text classifier?
So right now, today, when I talk about AI, we sort of segment it right now. There's this advanced AI category. These are these sort of chains that you're seeing with dependencies. It is an abstraction of LangChain today. The way it's been set up from day one, though, that's just one of the frameworks that we're using. So in future, as the space evolves, we can swap in other frameworks under the hood. So yes, this right now is an abstraction of LangChain, but a future text classifier in N8N, or one that you build yourself as a custom node, for example, we have docs for you to build your own nodes. It doesn't necessarily have to be.
Thank you.
Okay. We have one more question down the back. If you want to pass the mic for me along, guys, that'd be brilliant.
Thanks for the talk. So when things go wrong, what does the flow look like for the customers? How do they debug? Where did it go wrong? Because with LLMs, it's hard to make things go right. As in, prompts generally work, they don't work. Like, for example, LangChain, they have their own product for this observability. How does all those things come into picture here?
So I would say in terms of observability, let's have a look. We do have logs, for example, when you're working on this. That's not necessarily going to catch, if something at scale is happening wrong for a certain subset of your user base. That's not tooling that we would have in N8N today. That is something that we're assessing. But I would say when you're building your workflow, and this happens a lot in N8N, it depends what you want to catch for. So right now, the way this chat trigger works, and again, this is just a chat trigger. This could be a webhook. This could be any arbitrary, way that's starting this. It's responding with the output of this because it's the last step. But I could have an if node. I could check for certain criteria. We also have agents where you can output a certain schema. You can validate that schema. If that's invalid, you could route to something traditional. You could send a static message. Oh, sorry, something went wrong. We're texting a human, if that's what makes sense for your use case. Or you could have a multi-agent approach. Maybe here you have GPT 3.5 because it handles 90% of the cases, and then when it fails, you're routing it to an expensive model because it's really important that it gets it right. So what you do exactly depends on your use case, but I would say in N8N, the way it's structured, there's usually a flexible way to get that done and where you're not sort of locked in like most no-code tools, and that's why I would say the reason why we call ourselves a low-code product.
So those kind of abstractions on like doing reflection and whatever techniques exist to correct output, those don't exist as a top-level concept in N8N, right? If people want to build that kind of logic, if schema went wrong or whatever, retry, they have to build it like themselves right than that. How it was
So it depends. What I would say is for things that we see, on a bell curve, a lot of people wanting to do, we add a more opinionated node for that. The text classifier is a great example of that. The text classifier node did not exist 2 weeks ago because we saw a lot of people wanting to do that. The limitation of the text classifier node is that it's mutually exclusive. Only one of the options can be chosen. If you needed to choose all of them, there's an example in our template library that shows a more generic node where we set up a few more settings. So I would see over time, the things that most folks want to do most often, there will be an opinionated node for it, if there isn't already today. but you're not locked in if something you're trying to do kind of falls outside of that bound.
Excellent. Thank you so much, Max. I'm sure there's so many more questions, and you'll be around for networking
Absolutely.
to answer all of those. Brilliant. Thank you so much.
Yeah, and I'm happy for any questions. I'll be here for the networking.
Awesome. Great. So next up, we will have Apoorv, who is head of training at Analytics Vidhya. We'll just take a couple of moments to get set up.
All right, so good evening, everyone. Thanks for coming on a Wednesday evening. So I'm going to continue from where Max left. He showed a wonderful tool and very nice applications of agents. So I'm going to continue to talk about agents, dial it down a little bit, and talk about the need for agents, and perhaps use a little bit of coding to showcase an agent to you guys. Right, so I had the training vertical of Analytics Vidhya. I look at the development of courses. Analytics Vidhya is a EdTech platform focused on generative AI, data science, analytics. We have a lot of content on these topics, around 200 plus hours of content on generative AI topics and 500 hours plus content on data science topics. What sets us apart is that in our EdTech platform, we offer one-on-one mentorships to learners. Right? So we do corporate trainings. We have a very humble beginning. We started as a blog, and through that blog now we have a community of 4 million strong over there. Just a side note, Vidya in Hindi means knowledge, so it's like literally analytics knowledge as what this company means. Right. So coming back to the topic on why do we need agents to empower LLMs, right? So 2 years back, it seemed, why do we need to really empower the already powerful LLMs, right? But seems like they do need some empowering. So we know that large language models, conventionally, they have been trained on large amount of data. And then they reproduce the text based on the query that we have, right? So if we want them to create a proposal, if we want them to write an email, they use their existing knowledge to give us information. So if we have a query related to, what does NVIDIA do? It would already have trained on that data, and it would give us an informative reply on what NVIDIA does. But if we ask it, what is the stock price of NVIDIA, and perhaps for the last 10 days, that's where your large language models would fall apart, right? So ChatGPT is not just an LLM, it is also powered by a lot of agents, but this is a query that I typed in this morning, and the one on the right is the result that I got from Yahoo Finance, and the one on the left is what I got from ChatGPT. Bear in mind, ChatGPT does give the right answer sometimes, but not very reliably. So for example, the price, if you look at the closing price, it is indeed the correct one, but ChatGPT is giving the wrong date for it. Right? In fact, let's just try it out. All right, let's see. Okay, so this time I think it's doing a bit worse. So July 23, 122.89, that's the closing price. Let's check. I have Yahoo Finance. No, so 122.59 is the closing price, and that's saying 122.89 and does not give today's price as well. Right, so this is where LLMs can help us, right, to get that context which is not available with the large language models, right? In this case, the stock price. So some of the use cases that I think Max showed us, those are also very relevant. For example, accessing your calendar is what Max showed us, right? So accessing your calendars, perhaps looking at the meetings that you have upcoming, looking at the profile of those people, creating meeting notes for you beforehand. That's an area where LLMs would need a context, and then humanize the output for yourself. Similarly, prioritizing emails is another example that Max showed, responding to customer queries, and finally, what we were talking about right now, stock. Right, so let's look at the same query on a small agent that we have built, and let's see what is the response over there. So I'm going to head to a Jupyter notebook where we have this agent which can fetch data from Alpha Vantage, which is a popular tool to get stock data. And let's see if this works well. All right, so we are getting today's price as well. And let's see, 114.25. There is a drop in NVIDIA's price today. 114.25 is what Yahoo Finance is also saying. And we get the prices, not just the closing prices, but we get the open, high, low, close as well. Right, so let's further ask it, okay, what was the highest traded price in the last 15 days? Right, so let's see whether the agent is smart enough to tell us that. All right, so we get two outputs. One, we get to see which tool was being used by this agent. So there's a particular tool that we developed called Get Stock Price. Second, it says that the last 15 days highest price was 136.15. So interestingly, it looked at the data, realized that it has to look at the high price, right? And then gave us 136.15 from the last 15 days, right? So this is where the combination of agents and LLMs comes into play, right? LLM acted as a reasoning agent to identify which is the tool that we use, and then pass the information from what the agent collected over here, right? So that's what agents can do. Agents can get relevant information which was not utilized by the LLMs during the training phase, and then our LLMs can act as reasoning agents, one, to choose the tools, and then to make decisions based on that. In fact, let's try one more query. Over here, what are LLM agents? Let's see if any tools are being used in this scenario. Oh, so in this case, none of the tools are being used. So LLM is directly giving us this outputs on what LLM agents are. Right, so this is where LLM takes a call on whether to use a tool or not, and then accordingly give us an output. So this is a very typical workflow of a very simple agent. Think about it as a one single tool. When we ask it a common query like tell me about NVIDIA or what are LLM agents, the LLM directly gives us the response based on its knowledge, right? Whereas if we ask it a more sophisticated reply, which relies on current data, in this case, on the stock price for the last 10 days, the LLM looks at the different tools that it has access to, identifies the right tool, takes the action on that tool, call back the LLM so that we can get a humanized output to eventually give us a response. And this is a very simple flow. There may be a loop over here, there may be various tools over here, but this is a simple representation of what is happening behind the scenes. Right? So to get a better clarity of what is happening behind the scenes, let's actually look at a bit of code that we used to create this small agent. Right? So I'm going to start a bit of coding. Over here, we are going to use the common platforms. We are going to use LangChain. We are going to use OpenAI. I am using an OpenAI API key as well as an Alpha Vantage key as well. So coming to LangChain, LangChain has a lot of pre-built tools out there. I'm actually going to use the very first one over there, the Alpha Vantage one, which helps us get the historical stock price data. But as you can see, now there are many developers adding a lot of tools over here. We have AWS Lambda, we have DuckDuckGo Search. Google has a bunch of tools available, Google Finance, Google Imagine, Wikipedia is also here. So there are a lot of tools which are being built by community, which make it easy for developers to access some of them and build further upon them, right? So these are tools which help us fetch the relevant data. Wikipedia is also here, Yahoo Finance is also here. And we are going to use, let's say, AlphaVantage to showcase this particular query. To get the key of AlphaVantage is quite easy. You can get the free API key over here. The only concern is that it only gives 25 requests per day, right? So that's how you are limited, but otherwise it's free to get the key. Okay, so what I'm going to do is I'm going to use LangChain community to import AlphaVantage wrapper. And I'm going to access my OpenAI key as well as my AlphaVantage key using this piece of code. So the API for AlphaVantage works as expected. If we ask it to get time series, and let's say we are asking it for Apple, by default, it's going to give us the price for the last 100 days, right? So open, high, low, close volume of the last 100 days. Now, what we would want our LLM to understand is, one, what is the stock code? And depending on that, how much data are we really looking for? By default, we are getting 100 days of data. All right, so what we are going to use is, along with LangChain, we are going to leverage function calling by OpenAI, right? So with function calling, OpenAI sort of helps us in accessing relevant information for functions. It uses JSON format to access the key information over there. And we are going to use a decorator from LangChain called tool to get the relevant information. The key point while defining a function is this docstring, right? So when we are defining this function, we are telling it fetch last 100 days open, high, low, close volume of a stock symbol along with metadata. This is what the LLM is going to really use to fetch relevant information, right? So we create this simple function and we add a few try and except just to create some fail-safe measures. Now OpenAI has a particular format in which it requires functions. So we are going to convert this function into that particular JSON format. And then we are going to call the chat OpenAI API. While we are creating this model, we are using the latest GPT-4o model. We are going to bind it to this function that we have created, get stock price, right? So that it knows that this is the function that we need to run. All right. Now, once I give it a common query which has nothing to do with stock price, it gives a very standard reply, right? So like we were talking about the workflow, it does not go and access the tool. It just tells us, okay, hello, how can I assist you today? It's a response to hey there. But when we ask it, what is the price of Microsoft? One, it identifies that yes, it needs to call the function get stock price. Second, it finds the stock symbol for Microsoft, MSFT. We didn't feed it this information. It learned this information based on the docstring that we provided, right? The docstring mentioned that we are going to provide a stock symbol over here. So it found out the symbol for us, MSFT, and also told us that we need to use this function. That's all it is doing. It's not really calling the function. It's just identifying this is the function that we need to call with this particular argument, right? If we need to get the final output, we can devise a small function. We have devised a route function over here, which will actually tell it, okay, don't just get the arguments and the function that you need to do, actually run the function as well. So we are creating a simple LangChain over here to parse the output and run the function. Okay, let's ask the same question to it again. Our question was again very general, what is the price of Microsoft? But it's again giving us all the 100-day open, high, slow volume, because we have not fed this information back to the LLM and to the prompt to pass it accordingly, right? So that's the issue here. Also, it's not really a chatbot because this is a one-time kind of query. So what I'm going to do is I'm going to, in the interest of time, jump a few pieces of code and directly come to this part. So over here, I've added a couple of more tools for the LLM to play with. One is on searching Wikipedia. The other is a very simple tool to get the current temperature. And now we are going to create a full-fledged chatbot out of what we did earlier, and then prompt it with certain queries, right? So, for example, I think in the first week of August, I may be traveling to Dallas, and I would want to know the weather over there. So one, it tells us that, okay, given this prompt, one, it is using a tool called get current temperature, and then it's giving me the output. The current temperature in Dallas is so and so degrees Celsius. Second, if I ask it about Joe Biden, let's see, and I'm also asking to summarize it in 100 words. One, it says that, okay, it has used Wikipedia to get this information, and this is a summary in 100 words. 100 words is too much for us. Let's summarize it in 20 words. So now it's more like a chatbot. It knows what has been entered earlier and responds accordingly. And this is our initial query that we ran on the NVIDIA stock price, right? So this is a quick demo of what agents could do. They could access different tools. They could get relevant information for us and provide us with a lot of context which may not be present in the native format in the LLMs, right? Right, so I have a few applications listed over here. When we generally think about the use cases of agents particularly, we have to think, one, the dynamic nature of the content. Is the data that we are going to work on, will it rely on real-time information? Or will it rely on a context which is very specific to our organization, which is not present with LLM, right? So be it accessing our SQL databases, be it accessing our operations data, inventory data, and that's going to help us, okay, do we really need an agent over here or not, right? And if it's a one-time simple exercise, probably we are better off just using the LLM in its native form. So I have a simple set of scenarios over here, and maybe all of us can go through it and see what would be a better fit for us, a native LLM or an agent, right? So let's think about the first one, delivering personalized content by analyzing customers' browsing, purchase history, and preferences. What do you guys think? An agent or a good old LLM? Agent? So how many for agent? Can we have a show of hands? Right, so absolutely, agent it is because requires a lot of dynamic content over here. Right, so again, in the interest of time, I'm just going to show you all the answers at once. So yes, this one requires an AI agent. If there's a one-time thing that we just want a quick reply for a business email, LLM would do the job for us. Similarly, if there's a legal document that we need to summarize, it's a one-off activity, LLM would do the work for us. If it's a repeated activity requiring dynamic data, requiring real-time information, that's where the AI agent could really help us, right? So I think there was a question earlier regarding monitoring, right? So, and monitoring the performance of AI agents is very similar to how you monitor the performance of a machine learning model, right? You look at the KPIs, you look at the key factors which are going to probably push your agent to boundaries. So you try for those edge cases, you monitor the performance extensively in-house before you make it live. Even when you make it live, you have to have a feedback mechanism for the users to give back you a feed response that whether it's working fine or not, right? So standard procedures that we follow for LLMs, there are a lot of tools which are being developed for monitoring the performance of LLMs. And yeah, I think this is a field which is going to grow in terms of complexity and ease as well. So that's all I had in terms of AI agent. We wanted to give you a quick demo of how you could build one. As I mentioned, we are a learning platform, and since all of you are here, we would be happy to offer you a discount coupon if you are interested to pursue your journey on LLMs or data science. We are happy to help you. You can scan this code and send a query, and I would be happy to personally reach back to you. Right, so that's all from my side.
Awesome, thank you so much. I was going to say, is there any questions? Any questions, anybody? Yeah, okay, brilliant. I was going to say, if you can stand up for me.
Thanks for the demo. Have you built a case where you have multiple agents working together and what the flow would look like and what use cases you've encountered?
So, yes, and with multiple agents, the complexity comes in interaction between the agents, right? So you call a particular agent that relies on another agent. So the complexity is, I mean, with the tools which are available now, it's not very difficult to make multi-agents. The complexity comes in the time taken to get the eventual output, right? But I can share a few pieces of code with you later on maybe. And so with the systems available, now it's quite easy to build multi-agents, and I can share some pieces of code with you for that.
Great, excellent. Another question here.
Yeah. So inside the code, I saw that you put temperature equals 0, not the Dallas temperature for that stock prices. The reason for it is because you want to get the exact output.
Absolutely, right, absolutely.
Great. Anybody else? Yes, I'll pass you the mic here. Thank you.
Hi, thank you. Yeah, what's the difference of using like agents to like fetch specific resources versus using like RAG?
So RAG would more rely on the documents that you have on your server, on your basis, right? So you could think of agents as more specific to getting data from the web, using APIs to get external data, dynamic data, real-time data. So that could be a minor difference, but you could create agents with RAG as well, though. Yeah.
Another question here.
Similar vein, what's the difference, in your mind, what's the difference between the agents and the assistants in the OpenAI schema?
What's the difference between agents and assistants? Is that the question?
Yeah.
Right, so the lines are, I think, merging a little bit. ChatGPT used to have plugins earlier, which were more like agents. Now they have GPT stores, right? So even the definitions that we use, I think nowadays, agents, tools, functions, these are loose definitions at the best, right? So functions are a subset of tools, tools are a subset of agents. Assistants are, let's say, if you have to think about it broadly, assistants are easily maneuvered through prompts, whereas agents rely on external data, but again, then can be maneuvered with
Say
prompts.
that again, what you just said? Agents rely upon what?
So agents are sort of more maneuvered by the data that you get, right? But they can also be changed with prompts. So I don't have an exact answer for you, but the lines are a little blurred over there.
Thank you.
Right.
I was going to say, I know we have more questions in the room, but Apoorv will also be here for networking,
Sure.
and I'm sure folks will ask you lots of things then. Thank you so much.
Thank you, everyone.
Great. Next up, we're going to hear from Wordware, so they'll be talking about how to cut your agent dev time 100 times. We'll just do a little setup.
All right, hello everyone. Okay, and the sound as well. Perfect. All right. Still fixing my presentation, so guys, bear with me. Alrighty, hello everyone. I'm Filip, and I'm the CEO at Wordware. I've been playing in the space of LLMs for last 7 years, starting with BERT, following kind of research at Cambridge. And right now that GPT came around, we've kind of, current use of LLMs is chatbots, summarization, content generation, and knowledge retrieval. And as the person that was speaking before me said, we are entering the era of agents. And I actually have a very simple definition of what an agent is. And everyone is saying, oh, agent is such a concept that we don't know what it is. In my example, actually, it's extremely simple. So currently, the non-agentic workflows, so kind of zero shot, is as if I would put you guys in front of a computer, put a gun to your face, and say, now got to write an essay, and you cannot plan it, you cannot use any tools, you cannot reflect on what you write, so you cannot use backspace, and you cannot talk to people who are smarter than you. And you have to start typing at the same cadence right now. This is exactly how currently LLMs work. And it's pretty incredible, actually, that they do such a good job. But we need to move one step forward. So an agentic workflow means that you outline how you're going to write it. You can do web research. You can write first draft. You can then correct it. You can ask people who are smarter than you about how to make it even better. So very simple ways. There's 4 components to agents: planning, reflection, tool use, and multi-agent collaboration. And now, how do we actually build these agents? So we at Wordware believe that right now we can only do handcrafted agents. We are at a stage where handcrafted agents, where you code all of these steps in a specific manner, you have a standard operating procedure, work extremely well. Then we are starting right now to move to specialized agents. We got a couple companies which are creating something that you don't really know where the AI is going to go, but you give it a specific task. And then we have general agents like AutoGPT or React that can do anything. Nobody has put one of these into production. And now the main question, when you start building, you go to LangChain or you try to do a vanilla implementation of OpenAI. The main problem that we have currently is iteration speed is extremely slow, and the people who should be part of the iteration cycle are not able to read code. And in my opinion, that's why CodeGen has moved so far, because engineers are the people who look at it and they can judge the outputs of it. At Wordware, we approach it completely differently. We believe that prompts don't belong in the code base. I think it's actually quite ridiculous that in LangChain you have to move from prompts to code to natural language to LLM, which outputs natural language, which then you structurize it and you show it as natural language after the code again. And then the lawyers, the people who know exactly what to do, cannot start working on it. They cannot iterate. So we created, basically, in our opinion, the first IDE, which is focused only on AI agent building. And we've created a new coding language, which is mostly based on English. And now I'm going to try to show the power of it, because we'll try to go through a lot of examples. So kind of bear with me, all right? So first of all, as in any programming language, we're going to start with a hello world. So this is our IDE. This is where you build all of your AI agents. So I'm going to say hello world, as in any new language. And we're going to say hi to name. Name now created a variable. So we're starting to see there are some still similarities to coding, but the main programming language is English. We can now do a slash, and we enter a bunch of different options. By design, this is quite similar to Notion. So we're going to create a new generation, and we're going to call it greeting, and then we're going to choose from a multitude of different models, including the 405B, which we always add the newest models, so you don't have to go through all the hassle. So we're going to try to use Llama 70B in Grok mode. Actually, we probably don't need such a fast model, so we're just going to go 4.0. And from here, we kind of enter the magic of Wordware. Chaining prompts is extremely simple, and we've already seen that kind of separating what to give to an LLM yields superior results. So now we're going to say, make it polite. We're going to do another generation. So there's a bunch of shortcuts. This is a power tool for creating agents. So now I'm using a curly bracket to say polite, and that creates a polite greeting. And then from here, we can, for example, say, write a story about this person. And we're going to say story. And because that's quite I'm going to say, create a long story about this person. So story here, actually, because it will be quite a lot of text, we're going to use Grok. We're actually very very fond of Grok. Grok is a kind of a new infrastructure on how to run LLMs very, very fast. And they were essentially very lucky in the fact that they designed 7 years ago the exact right architecture for LLMs. All right, so now we get to do a couple things. This right now is a runnable prompt. So I can just go Filip, and this will show me exactly what is happening. So when I said, oh, we got a very long story. Okay. When somebody asked a question in the audience about observability, we actually think that right now, observability and ability to quickly iterate is one of the most important things. We have learned that with software, that the quicker you can do iterations, the better the software is going to be. I think right now, LLMs are being treated as either it works or doesn't work. And people don't spend enough time on iterating. And the really important part is that you see where it went wrong. That's why here, anyone can see exactly the outputs of the LLM. You can then access your runs. And if you're dealing with somebody who is not technical, you can deploy a new application. Well, let's just deploy it here. I'm going to generate an image automatically. That takes a second. 1 sec. Will it be quick or not quick? Okay, I'm going to publish it without it. And we have a deployed application right now, which is basically available for anyone who, even if they don't want to enter the editor, when you have a legal use case, a lawyer is writing a contract and they are the technical person. They can actually write out the whole flow, and they can then share it inside of their legal firm to say, hey, use this. This is an internal tool. I've used all of the best practices of our law firm in order to get this done. So if I write it here, it's very simple. I'm going to run this app. It's extremely simple. It's producing the same result. This is immediately also accessible as an API. So we have people who build these kind of LLM backend on us, and then they can deploy it as an API, and they can use it inside of their product. And in a way, what we are trying to achieve is this community of people who are writing LLM backends, share it in a GitHub-like style. Anyone can reuse it, and we become the main tool, the main IDE for all of the LLM backends and all of the cool applications. So speaking of cool applications, we of course have a lot of enterprise customers, and we spoke about all of this knowledge retrieval. But today I'm just going to focus on fun uses of this application. So from here, the first thing that I wanted to do is I'm going to live code a research topic and create an engaging story. So I fall asleep to audiobooks. And sometimes I have this one book by Dostoevsky. Some people might love it, but it just makes me fall asleep really quickly. But sometimes I want to learn before I fall asleep. So this is something that I wanted to do. So I'm going to say, your job is to put me to sleep through a boring story about I actually really about a topic, so we created a variable. Firstly, plan out a storyline which is factual about the topic. And you know what? Before this, we should research the topic so we make sure that it's not hallucinating. I'm going to use another generation. So we've got a bunch of different options here. So we will use a generation which uses Solórzano, which is an online-enabled model by Perplexity. And it's actually amazing. Everyone should be using it. So we'll research the topic. Firstly, plan out a storyline which is factual about the topic. We're going to do a plan, which is factual and engaging about the topic. I normally, for most things, use Claude 3.5 Sonnet. And then we're gonna generate the actual story. It should be long because it normally takes me add minutes to fall asleep. And then from here, we're gonna do the whole story. And we're gonna now use more functionality of Wordware. So these are only chains right now. So chains are perfect. But what about the actual, all of the other aspects of the agent? We go to the slash command. And then from here, you've got structure generations. You can ask a human to basically stop the flow of any chain of thought and correct it in a deployed application. We see that used quite often. Even if you design this perfect flow, sometimes it goes off rails and you need to put it back into its place. We can do loops. We can do code execution, so you can write any integration you want. You can connect to any database. We have also, of course, conditional statements and kind of prompts. And prompts is basically it's basically something that calls different functions. So because I wrote this in the wrong place, I'm gonna copy all of this and go back to the place I should have wrote it in and create a new prompt and paste all of that stuff here. And we just got research, and we add the real stuff, topic. Everything else should work, add minutes, perfect. And then from here, we're gonna use a tool. We've got a bunch of different tools like web search, web scrape, creating images, but we are gonna use just something which is a little bit simpler, which is 11 labs. So the content will be the whole story. And then from here, we're gonna add the output of this function. So you can start seeing that we're getting closer to real programming. So topic is gonna be tank battles during World War II. I don't know if you guys do this, but I fall asleep to documentaries about World War II. So we have research happening, you know. I should have probably said that it should have used just one of these, but we're gonna continue. So this will run in the background, and I'll start taking you through new stuff. So the next thing, and I'm gonna kind of rush through these. So the next thing is creating a personal website. So I don't know if you guys ever created a personal website for yourself, but you're gonna be able to in a second. So we do research, we use different models, we use quotes, etc. And then we write a poem about the person, we read it out loud using 11 Lab speech synthesis, and then we create a website. And this is something that actually came from our community, and this is exactly how we imagine it. We imagine people creating some things that we didn't know are possible, because we always got annoyed with no-code tools and about the ceiling of it. And we actually have no ceiling, at least we haven't found something that cannot be done inside of our software. Then this is actually hosted on our server, which we didn't know is possible. And I'm gonna run this for myself. Filip, Kozera, founder at Wordware. And we're gonna run this. So the next, what I would like you to do is I'm gonna deploy this application, and I'm gonna publish it. And I have a published version that I copied the link. And now I created something which just reuses a bunch of this stuff, and it generates a QR code. So I will run this as well. And here I will input the URL for the application I just created. So this is right now writing code, which is HTML, which is gonna essentially create a QR code about a hosted version of this personal website. So all of you in a second will get an ability to scan this code, and so take out your phones, guys. Hopefully this works, and you will be able to see what AI knows about you. So we got this big QR code. I'm gonna zoom in on this. I have no clue if it will actually work, because, well, AI did it, right? It wrote all the code. And after it, you should, oh, sorry, go for it. Okay, so does everyone have it already? Cool. All right. So next, let me just make sure that I'm on, next, I'm going to show you mine. It's a little bit embarrassing, but we'll see if, not the right one, not the right one. I think it's this one. Okay, still writing actual my personal website. So you can start typing in your name and see how basically it does. It will take a couple minutes. So I'll let you do that. And in the meantime, hopefully this will, in a second finish it. So type in your names, type in as much detail as you can, because these models will try to find you, especially if you have a generic name. Okay, so moving forward, when I was sitting in the, okay, we got this. Okay, it gives me an online presence. It's basically researched all of my links. It tells me that I worked really hard, which is fun. This is how AI envisions me, apparently. And we've got a poem as well.
In the heart of tech, where ideas glow bright, stands Filip Kozera, a beacon of light.
You know, like, the cringe is pretty bad for me. So.
Vast as seas.
All right, that's enough. But you'll get a personal website in a second. And let me move on. When I was sitting in the crowd, I noticed the LangChain deployment of this Alpha Vantage trying to find the price of NVIDIA and how ridiculously complex it was for me. So I just basically said, write a code to check in price of NVIDIA, act as an expert JavaScript programmer. I then said to Claude, hey, write it. Claude sometimes says, here is your code. So I wrote a quick function which strips the code, and then I hosted all of the code and ran it. So the price, I'm trying to check the NVIDIA price. My agent wrote some code and it got the price. So that's how quick that was. And then we got the next one, which this is a really fun one actually. But I wanted to say something about this one as well. Oh, so kind of a more practical use case of this that we are in production with a company is they have a bunch of different, they are a tracking company, and they have a bunch of different databases, which you can call into these databases for an endpoint. And then they specified in the prompt, I can't show you this unfortunately, the structure of what you expect as the output of these functions. And they have very complex questions from their users who ask how many times was I overcharged by the 400 different tracking people that move freight for me? And this agent writes all the code, crunches all the numbers, and in 45 seconds outputs a beautiful report. So this is an actual use case of all this fun stuff that we're talking about. And one of the last parts is a basic React agent where it's supposed to essentially think. So writing this particular agent in other softwares is extremely difficult. We are dealing with something which is quite general here. All of the stuff that you see here is part of a prompt. So this is how we start to realize that coding now becomes prompting. And people say, oh, but it's just a prompt, it's just a prompt. No, this is going to be the future of how we talk to these monsters that are LLMs, that are just wearing human puppets because of reinforcement learning through human feedback. And we need to learn how to chat with these monsters, and this is what AI engineers and prompt engineers are going to be really good at. So we give this AI agent some tools. We give it a format of how to think. We tell this monster, hey, this is what logic looks like. This is how you should think. We then run a loop, which basically does the reflection. It always tries to figure out what it's done wrong. And we use a structured generation to include thought, action, and input. Structured generations, by the way, are underused, and I'm really annoyed about each client who comes to us and says, you should oh, I don't know what structure is, so I shouldn't use it. Then we use the tool selection, and I actually created a question about what is the NVIDIA stock price today, and I also said find also the highest price in the last 15 days, which you might recognize this one. And we can see it's finding that it needs to firstly do Google search. It then realizes that it needs to use AlphaVantage API. This agent now writes its own code. It runs its own code and gets the exact answer, 136.15. So again, this is a QR code where you can try all of these things. 1 second, that's not the right QR code because I wanted to share something more fun as well. No. The really fun thing that I wanted to share is, wait. Is that the one? QR code, copy. Okay. So the next one we're going to do is a Lego, turning yourself into a Lego fixture. We are by default multimodal. You can put audio, you can put images, you can do whatever you want. As long as you can see it, it can be fed into LLM. We're now using these kind of sub-prompts, like describe images, write image prompts, checking image prompts, and generating stable diffusion free. And we can run it with a photo of you guys sitting here. So I took this photo, and what it outputted, this takes around 30 seconds. Let's see what it came out with. But this is the Lego version of all of you guys. So the really fun part about this is I get to deploy it again. I get to publish this up. I get to take the URL. I get to run this one. I get to put it here. I get the I get one of the models to write the whole code, and then we'll finish with the code of each one of you being able to take a picture of yourself and turn yourself into a Lego figure. And lastly, I have created this page for you guys. Wordware, we have an exclusive promo code for everyone. You can start for free. Please build all of the agents you want, but there is an also 50% discount on Wordware for AI, it's called AI users. So, okay, and lastly, this is, you like sufficient credits, please purchase more credits. Oh, that's a little bit annoying, but I'll show you one more. I was swimming on, no, you don't know the original. Never mind. Okay, I'm at time. We built quite a lot, I hope. Yeah, that's basically us. That's Wordware.
Thank you so much. Thank you, that's brilliant. I want to check and see if there's any questions in the room. Yeah, you can put your hand up there. Great, and pass the mic along if there's anybody else.
So when you tell the agent to do research, where does the agent look information?
So there's a couple different options. So when you go to Wordware, we are quite opinionated about what to use. So when you create a new project, you got Exa search, you get Google search, you get to do RAG with Trafalpig, actually very good provider of like vector databases, Wikipedia, u.com, and also those are the tools that are readily available in Wordware, but a lot of our clients actually write their own JavaScript code and query their own databases. And additionally, there's two models which are online enabled, Command R plus online by Cohere and Sonar Large by Perplexity. Sonar Large is better, so I would recommend using that. And you can even ask for sources. So mixture of these things and actually having the domain expert being the front chair. A bunch of our clients are actually researching topics that they know about and putting the right flow, but then asking the domain expert to like check whether it's working and tweak it is the really important part.
So you can search for specific like URL, for example?
You can. It's actually called scraping, web scraping, Firecrawl scrape.
What about like if you want to tell the agent to study from a PDF file?
So in a PDF file, actually, we are, again, quite opinionated. RAG with Trafalpig, you input a URL with a PDF, and it automatically puts it in a vector database. But also, I would recommend using vision models for shorter PDF documents because they output better stuff, and they transcribe it, and as long as the context window, the content is in the context window, you can deal with it. So RAG is not only about vector databases. It's another thing that I get annoyed about. It's actually vector databases are not that good.
Excellent. Anybody else, guys? Yeah, super. You pass that along for me there.
So when you're debugging, when it, in maybe the 1% times it doesn't do well, do you output like log files of each step so you can kind of figure out how to tweak the workflow? Do you have your own debugger tool, or you just output it to something else that could expose the steps?
So our editor is a WYSIWYG editor. So it's what you see is what you get. When I'm running, for example, this research topic and create an engaging story, I immediately, I'll go tanks again in 7 minutes. I immediately see what is each model doing. So right now, our evals, we do hook into other evaluation tools, but at the same time, we believe that LLMs are so early that most people don't have ground truth. How the heck am I supposed to know what's a good story for me to fall asleep, So we say vibes plus a lot of iterations plus seeing the whole trace of how it's thinking is the solution for higher quality agents.
How do you prevent like regressions? Like in the act of doing something well, it might get worse, like as a fallback,
That's prompt engineering. You can get really far with prompt engineering and with kind of specifying the model into that particular way. I actually think most of the time it's like if you do really good prompt engineering, it's better. Like it's often as good as fine tuning. And yeah, so essentially prompt engineering, 2 weeks of iteration. That's kind of the answer.
Excellent. Thanks so much. Any final questions there? Yeah. Cool. Last one.
So you mentioned 11 labs, and that is not free. So if a user wants to use that service as well, like on top of the membership fee to you guys, then there is an extra charge as well?
No, because it's a lot of work for us, so we just give it for free. Yeah, and we also a YC company, so these people give us like ridiculous amounts of credits. Like my DeepGrow account, I got $500,000. I'm like, what the? How do these people make money? So, long story short, we give everything for free for now.
Excellent. Thanks, Philip. It's brilliant.
Thank
you.
you.
Around for networking. More questions? No? Okay.
All right, one last chance. This is the Lego. So, sorry, is this the Lego? This is the Lego. It's actually really fun. It's pretty good. So if you can scan that. All right, share it on our Twitter or LinkedIn, please.
Yes, sir. Great. Okay, next up, if we have signal. Next up, we will have Daniel, who's going to be talking to us about unit testing LLM-based features. I'll let you.
All right. Thank you guys for sticking around and coming to my talk. And thank you to AI for Developers for having me. And thank you to my girlfriend who lent me her laptop. It's my #1 sponsor today. Today, I want to talk about testing AI apps. And I actually want to echo something that Filip just talked about, which is that iterating very quickly on an LLM application, right, is the quickest way of converging to the kind of performance that you care about. That's something that I have found working on my own applications and that my friends have found. And what we're going to talk about today is how testing is the key ingredient that allows us to get those iterations in and converge to the performance that we want. And this talk is specifically focused, on tooling for full-stack engineers that are building AI applications, right? So I think we're switching from a paradigm in which most of AI applications were built by ML engineers, and now we've sort of seen that process democratized and become more accessible to different people. But I think what's missing, it's a gap in tooling for people who do not have an ML background. So let me tell you a little bit about how we got started with this project. So I'm an ML engineer in Cruise, so I work on AVs and I focus specifically on testing. And my friend, he's a full stack engineer at a marketing company. And he was working on this really cool little application that basically would allow a marketer to provide a description of a marketing message. And then it would create a liquid template for that. So this is a templated language. And what it allows the marketer to do is to basically personalize the marketing message based on the products that their users have used. So he built this. It was pretty easy, right? You can just use the OpenAI API. But then he ran into a hiccup, which is, well, now I have this. How do I test it? And he didn't really have a simple answer to this question, which feels very basic. So why did he struggle with this? I think the number one thing to be aware of is, AI systems are very different from a conventional software system, right? They're not deterministic. Even, if you set the temperature to 0, for example, if you change one word or two, it can change the output significantly, right? And it's really hard to write code tests, that can target, a system that's so sensitive in that way. Another aspect of AI-based systems that's important to consider is that sometimes the questions that we want to ask about these systems are very open-ended, right? So we're not trying to compare some output from a function to like a float, like to an integer, We're looking at open text, right? It could be, some sort of support agent that's generating a response to a support case, and that's a really hard kind of data to write, code tests for. So that's one of the parts that, for which AI represents a paradigm shift. The second thing that, we noticed when my friend was looking for a tool is that a lot of the tools that are available are geared towards ML engineers or non-technical users, right? So, a lot of the libraries that we saw online, they're written in Python, they're configuration driven, they're talking about concepts like labels, metrics, et cetera. And these are not the types of concepts that someone who's a full stack engineer might be familiar with. I was actually talking to someone earlier exactly about this. Another thing is that, outside of the code itself, like the guides and the documentation and the abstractions are not really written for the full stack engineering audience. And finally, for some of these tools, there's, unnecessary, sort of like UI or SaaS components that developers at least don't want. I will say, I think, in talking to a lot of people and having friends who are doing different companies, I think that there's definitely an audience for tools that are, lower code, right? But there's also an audience for, developers that want to work within their standard IDE. And so I think there's sort of space for all of these people, in sort of this new realm of AI tooling. So what did we do? What we did to solve this problem was that we built Poyro, right? And what Poyro is a simple open source V-test-like framework that allows you to test your AI app in JavaScript. So let me go through each of these points separately. So it's simple. It literally has 2 functions in the SDK. It's the simplest thing you could use. It's open source, so you don't need a license to use it. You can just clone it and use it wherever you want. It's using V-test, so the most popular framework for testing in JavaScript is Jest, and V-test is a modern version of that. And it's no cost, which I thought was important because one of the things that made us hesitant to test our AI apps is that you had, some AI tests that you might want to run require you using an LLM to evaluate the output of another LLM. And you don't want cost to be the thing that prevents you from iterating quickly. So what we did in this case is that we give you the option to run a local LLM. And it might sound like that wouldn't work super well, but with the speed at which local LLMs and open source LLMs are moving, it actually works a lot better than we initially thought. So we wanted to give support for that. So one of the things that we have learned in talking to people is that, people are not lacking evaluation libraries, right? I think there's probably like, 40 of them, right? But what is missing is content showing what this looks like in real life. So that's where we've been focusing a lot of our energy, and what I'm going to be presenting for the rest of the talk is basically a case study where we worked with a company that was building a legal AI application and wanted to figure out how do we test this thing so that we know that we can trust it. So let's dive in. So what are we testing? I want to show you a screenshot of what this app looked like so you have a sense of what we were writing unit tests for. So we came into contact with a startup called Outlet AI, and they are building a legal assistant for revising sales contracts. The way that it works is they have a web app, and you can upload a contract, And it's going to read the contract, and it's going to find areas of the contract that are problematic, that are going to give the client risk, right? And so what you see here is the first step where you select which agents you want to run. Some of them are focused on just contract risk. Some of them are focused on compliance. Some of them are focused on negotiation. We're going to dive deep specifically into the negotiation agent. So here's an example for what a recommendation looks like. So this is a section of the contract, section 4, where we're talking basically what's being discussed here. I'll give you the TLDR. It's a little dense. It's discussing the pricing of custom services that the seller is going to provide to the buyer in addition to the core software. And it's basically setting the terms by which the seller and the buyer are going to agree in that pricing for those additional custom services. So this AI agent is basically identifying that there's a clause here in red where it's basically giving the buyer the freedom to charge the seller the freedom to charge the buyer whatever amount they want for the cost of the additional services. And what the negotiation agent's noticing here, if you look at the example, is it's noticing that this might make the buyer reluctant to sign this contract, right? Because it doesn't give the buyer any protection in terms of the services that might get done. And finally, in green, what we have is based on this reasoning and detecting this bad clause, we're going to replace it with this new clause that's going to set some limits to how the seller can basically assign costs to the services that they provide to the buyer. So now that we understand the app, the question is, how do we test an AI legal assistant? And this is actually a question that we struggled with, right? Because Outlet came to us and we're like, how the hell do we do this? How do you break down the concept of analyzing a sales contract, right? And actually make it into something testable, right? So the way that we went about it is, this is where working in the AV space was helpful, right? One of the things that I learned at Cruise is that, complex AI systems are just like complex software systems. But what I mean by that is that they're decomposable into components, right? So in a self-driving car, for example, you have different ML models, different AI programs, right, that are responsible for different things, right? And what this example is trying to illustrate, this is actually a project I worked on, is the example of a web agent. This is an agent that could use AI to navigate your browser. And you can see that this is a large system that can be broken down into steps, right? So one step might be you choose what action to take on a page. Do you navigate or do you interact with the current page? If you choose to navigate, how do you select the link to navigate to? So we can take this fairly sophisticated system and break it up into subcomponents. And then once we've done that, it's much easier to define what success means for each of these subcomponents, right? So for example, for this first one, if you're choosing what action to take on the current page, you might go through all of the, the pages that you want the agent to navigate through and basically write down what the actual action that it should have taken should have been, and then compare that versus the action that the agent actually took. And then you can calculate the accuracy of the agent in making this action selection. But the key thing that I want to give you to here, that I want you to take away is that, we can decompose any of these complex systems into subcomponents, and then we can come up with measurable objectives for each of those subcomponents to test. So the same is true of this legal AI system. I would say that it can be decomposed into 4 parts, and there's actually 3 critical ones that we're going to focus on. So the first part, if the system is obviously the input, right? So you're inputting a section in a contract, right? That's this whole blurb here, actually, ignoring the title here, just the paragraph, right? So this is what we're feeding into the system, right? And then the system is actually producing 3 distinct outputs for us. And how those are sequenced doesn't really matter. What matters is that we can decompose them into 3 outputs, right? So the first one is that we're coming up with a substring that we're going to replace in the contract, which is in red, right? And the way that we're going to identify that is by figuring out the index at which that substring starts within the larger section and the substring or the index at which it ends, right? The second thing that our system's generating is a proposed replacement string. So that's the string that's in the green. And this is a component that we can test independently from the substring that we identified for replacement. And finally, the last thing that's a critical part of the user experience is to make sure that we're providing a reasoning to the user that makes sense to them and that actually helps them be successful, right? This is not supposed to be an AI lawyer. It's supposed to be an AI legal assistant. The user, at the end of the day, needs to approve the changes, and if they don't understand them, then it's not going to be very effective, right? So we've decomposed the system into 3 parts that we can test, and now we can think about how do we assign measurable objectives to each of these, right? So the first one's actually really easy, right? We can read, like a test contract ahead of time. We, can consult with a lawyer, right, or consult with like our internal team, like which is the clause that should have been detected by this negotiation agent within this section, and then we can check how the actual substring that should have been detected by the system would compare with the string that was actually detected by the system. In the second case, this is the more ambiguous part of the system in terms of testing, and this is the one that we struggled the most with. So, we are generating a proposed replacement string, right? That's going to replace the clause that we removed. And what we wanted to figure out is how to measure whether the replacement is good, right? But whether a replacement is good from a legal perspective is a really open-ended and ambiguous question. So we had to, talk to experts, right, and figure out like what does it mean for, like a clause in a contract to be good. And we came up with some example criteria, right? So one of them is, well, if you insert a new clause into a contract, you need to make sure that it doesn't contradict the rest of the contract. Because if it does, it actually makes that section void, right? And that means that your recommendations are actually damaging the contract rather than enhancing it. The second thing is, we want to not rely on the internal knowledge of the model that we're using for the AI application to come up with like recommendations. What the best practice is to go to a lawyer, compile a list of best practices, put that into a text file or a database, and then when our agent is reading the contract, we're going to pull from those to make decisions about how we're going to update it. So when we are going through our test contract, we want to make sure that we can attribute the change that we're proposing to one of these best practices that it's in our database. And this is sort of how we broke down this complicated question of how do you measure if a proposed clause in a contract is good into measurable objectives. And then we'll get to how we actually measure them. Finally, we need to make sure that the reasoning is good. And our definition of good in this case is that we wanted it to be accessible to someone who is a non-legal staff member for the startup, right? So, a lot of the startups that are needing to rely on this kind of software, the reason they need this kind of software is because they don't have a legal team. They're usually at an early stage. And so that means that you need to provide reasoning that's, accessible to someone who's not a lawyer. Great. So now that we've gone through that, I want to take these ideas in terms of how we broke up the system into tests and then see how they translate into actual unit tests. So here we go. So for those who are familiar with Just or JavaScript, you may be familiar with this kind of syntax, right? So this is the way that we segment tests when we're using Just, right? Basically, a describe is just a chunk of tests that are related to one another, and an it, in this case, represents a single test case. And for this file is measuring that first component that we wanted to measure. I'll go back here. So the first thing that we wanted to measure here is, are we finding the right substring in the clause that is problematic, okay? So that's what this test is doing. You can see here that we have the full text for the section, right? Which we want as a reference because we're gonna get a substring out of this. And what we've done is that we are gonna basically, write down the expected value that we want our agent to extract for what that bad substring should be. So in this case, it goes from 83 to 347. And if I highlight that in this text, what it should be picking out is the last two sentences. So the last two sentences in this section are the ones that are problematic, and those are the ones that should be detected by our agent. Over here, we have a method that's basically spoofing the action of our agent. And what it's doing is that it's reading the section, and then it's figuring out like what it thinks the problematic clause is in this section. And in this case, the agent is going to think that this last sentence is the sentence that has the problem in the contract. So the agent in this case is failing because it should be detecting these last two sentences as problematic, but in practice is only detecting this sentence as problematic. So we're not detecting the full part of the section that has issues. Great. So having defined, our target substring for what we want to remove from the contract and what the system's actually detecting, which is, again, is this single sentence here. It's what it's actually detecting. We can use a method, just using code, to determine how much the substring that we want to remove overlaps with the substring that our system actually removes. And I'm not going to go through the details of this method, but all you need to know about it is that it calculates a number from 0 to 1. It's 0 if there's no overlap between those two substrings. It's 1 if they overlap perfectly. And if the overlap's not perfect, it's some number between 0 and 1. That's all it is. And so I can run this pretty easily here. So I will actually filter for this test, which is number 1. And here we go. So this is the output. So I actually have some logs here to show what's happening. So this is the problematic part of the section, right? This is the part that our AI agents should be extracting. And you can see that there's 2 sentences here. And this is what this AI system is actually detecting. So it's failing to detect the full text that is problematic. And so if I print out this overlap metric, it's saying that the overlap is only 50%. So I've only captured 50% of the problem text that I needed to detect with my AI agent. And in this case, it fails because we set the threshold to 80%, right? In practice, you're never going to get perfect accuracy for an AI system, right? So that's a reasonable threshold. So I hope that illustrates how you can use just simple code, even to taste an AI app. You don't necessarily need to do anything fancy to get started getting signal on whether your system's doing what it should be doing. So that was for the first case, which was basically making sure that we are highlighting in red the correct part of the section. Now we're going to go to the second case, and I think I might only have time for this one before I go to questions, which is, we want to check that the replacement that's being generated by our legal AI assistant is good, which again means that it's consistent with the rest of the section. So that's everything that's left here in white that's not deleted, right? And whether we can attribute it to some best legal practice, okay? Before I go into the code, I want to point out something that I think will help you understand how, how the code sort of plays out, right, or the test. So if you read the replacement clause here in green, you can see that it says here that the seller will provide binding estimates, right? What this means in plain English is that the seller is going to commit to a cost for their services, right? Which is the problem that was in the contract in the first place. But if we go to the white, you can see that, let me see. Yeah, so you can see here at the end of this sentence that we're not removing, that it says that the seller's estimates are non-binding. So what this means is that what we're keeping in the contract actually contradicts what we're inserting into the contract. So we actually run into this issue. And this is a real example. I didn't make this up. This actually happened. So now that we know that we expect that consistency check to fail, we can go back to the test and understand it. Great. So that's this second file here. And so let me go back to the top. And actually, it might help if I just run it from the beginning. So we'll have that there as a reference. So as that runs, I will have that. Yeah, you're seeing like the outputs from the model or from the testing framework printout. So you can see here we have the same section that we're working with, right? We have our first test, which is we want to check that there's not a contradiction. Okay. And basically what we have here is that section minus the clause that we're going to remove. So this is the section text minus this red. It's the text in white, okay? So we're going to compare this with the text in green here to look for a contradiction, okay? So that's the replacement clause. This is the text in green in that picture. And so what we're going to do is that we're going to run this assertion here. And what this assertion does, it's really neat. It's basically, it takes that replacement clause, so that text in green, it specifies a natural language requirement, right? So an assertion in natural language. In this case, we're saying we do not want this to contradict any of the text that is passed in here. And as you might recall, this variable here is the text in white. And so this is actually, the addition that Poyro gives on top of vtest. This matcher is not part of vtest. This is what we've added to it to allow you to run what are called LLM-based tests, which is a test in which you're using an LLM to evaluate the output of another LLM. And when you run this actually by default runs locally on your computer, and it compares the text output by the application LLM to your criteria that you specified here, and it returns a binary condition of whether it meets it or does not meet it. So if I go here, this is actually that first test that we just went through running. And you can see that it explains to us why it failed, right? We have this local LLM that's explaining to us why this criterion is failing. And in this case, it gets it correct, which is, it's saying, the response that you gave me in that first variable says that the seller's gonna, provide binding estimates. But the original text that you gave me says that those estimates are non-binding, therefore, I'm gonna fail this test. So, this is how, using LLMs for testing and extending v-tests with Poyro allows us to test some of these more open-ended cases, where it's hard to write code tests for. So that's the first case. In the second case here, we're looking to make sure that we can attribute the recommendation to a best practice. In practice, these best practices would come from some sort of knowledge base, right? It might be a text file, it might be a database. Here, for illustration purposes, I have them as an array, right? And we also have our replacement clause, right? And what we want to do here is that we want to make sure that our replacement clause, which is this one, can be attributed to one of these, recommendations that a lawyer gave us that we put into our application, right? So if we reach through each of these, we can see that, for the first one, it doesn't make sense to attribute the replacement clause to this one, right? So the first best practice here says that the contract must establish a structured dispute resolution framework. Basically, it's saying that the contract needs to tell us how the seller and the buyer are going to resolve conflicts, right? But this replacement clause doesn't say anything about conflict resolution, and that was not the intent, right? So it's not going to match that first one. For the second one here, the best practice that we have here is saying that, we basically must have some, statement about warranties in the contract. And again, that's not the goal of this replacement clause, so we're not going to get a match between this one and that second one. But in the third one, in the third best practice here, we're checking, that the contract is giving financial clarity and planning regarding costs. And that's actually related to this recommendation. This recommendation is about making sure that the seller is communicating costs upfront to the buyer. So we would expect that we will get a match to this third one. So what we do is that we basically do a for loop across each of these best practices, and we run this function that Poyro provides. This is the second one that basically can, compare, some sort of like, input to some sort of context, through the lens of some criterion. In this case, the criterion is that we want to be able to attribute this replacement clause to this best practice, right? And you can see it's very simple. It's always 3 arguments, right? We're gonna get, a JSON response. And then with that JSON response, we can basically check if we got a match for any of them. And that's what we get at the end of this for loop. So when we run that code, what we get is this right here, right? So I'm actually logging what the matcher is returning. And you can see that as expected, the first best practice is not a match for the recommended update for the contract. So, we get a false and we get an explanation saying, this is not a match because this is not talking about how to resolve conflict. For the second one, we also get a false and it says, this clause is not, discussing anything about a warranty, so this is not a match. But for the third one, we get true, and it's because this clause that we're replacing with is establishing a way for the seller and the buyer to agree about costs, which is what we were checking for. Great. So I also have a third example. I want to leave time for questions, and I don't want to run too late. But let me go back here. So this is our repo. If you want to play with Poyro, there's a few reasons why you might want to play with this or go to this link. Number one, this whole presentation is present there as an article. So if you want to go back and refer to it, you can read it. I know it's a lot of content, it's a lot of code, but you can go there and you can actually get the code in a runnable format. And you can also get an entire article explaining how we went through this thought process. The second thing is, we have docs that make it extremely easy to get started. It's a single command, and that will add v-tests and Poyro to your project. And that will allow you to start writing tests like this. And finally, we have a lot of different examples there in different articles about how to write tests for other use cases. So we have, examples for like optimizing SEO. We have examples for like marketing, like the one I showed earlier, and we discussed some of those. And we would love to hear from you. If you go there, you can find the link to our Discord. We love working with people and helping them brainstorm like how to test like their specific use case. That's what we did with Outlet for this particular example. Hearing about how you do evaluation and hearing your feedback. What do you think? So. Thank you.
Thank you, Daniel. Brilliant.
Hey, quick question on, so I understand the overall idea behind it, but how do you make sure that the LLM test that you're writing is accurate in testing your stuff? Are you becoming cyclical?
Yeah, that's a fantastic question. I kid you not. So my friend that's working on this with me presented today and got the same question. So this is a very common question. So there's different levels to this, right? The first one is that when you are training or you're using an LLM for evaluation, you can take a test set of evaluations, right? So just how you would evaluate, you can evaluate the evaluator. And you can actually check for the alignment between the evaluating model and human judgment. And one of the reasons why this type of testing has gotten popular is because people found that these LLMs were actually more aligned with human judgment than any sort of rules, right? So that's one way that you can go about it, right? The other way that you can go about it is there's actually, and this is something that we do before we update the model that runs. So there's a data set that was created by a team called Prometheus, and they have 100,000 examples of evaluations, right? And you can actually take the model, right, that we're using and the prompt that we have, and I can run it on like 1,000 of those, 10,000, 100,000, and see how often it's correct or not based on the Prometheus rubric, right? And then I've actually used that to iterate on the prompt or decide which model you use in order to do the evaluation. So I hope that answers your question.
Hello. Just two questions, really. The first one, I'm not sure I've exactly understood how you do the last test. I mean, you calculate some embeddings and compare vectors, or?
So, sorry, is that the end of your question, or should I?
Yeah, no, and so the second question is more, is it, are you aware, or does it exist a similar framework in working in Java? Or,
Yes, good question. So to answer the first question, what's happening here is we're actually prompting an LLM, and we're asking it like, here's the output of your application LLM. Here is the rubric that you're going to use to evaluate that output. Do you think that this output meets that criteria, yes or no? So you could actually feed our prompt to ChatGPT and it would do the same thing, right? It's actually very, very simple, but it's been found to be really effective. And the output of that LLM is a JSON, right? So this is coming straight out of that LLM. You know, we basically tell it, this is the format that we want the response in. Can you just conform to that, right? And we have found that to work really well, and a lot of people have found that to work really well. And the reason, you know, this is additional content, but the reason why we generate the feedback, besides the fact that it's user-friendly, is that it also guides the evaluation, right? It's like a chain of thought, basically. So that's to answer your first question. Your second question, I have not seen a lot of tools that are specifically tailored to Java. There's a lot in Python, there's a few in JavaScript, but I think that, you know, the set of support is slowly expanding to other languages.
Okay, brilliant. Thank you so much, Daniel. You'll be around for networking and
Yes.
more questions with everybody. Brilliant. Another round of applause for Daniel, please. Great. Just a few quick announcements from me before we wrap up. If you enjoyed this evening and you want to show some support, seek us out on socials. We'd love to, if you recommend us to a friend or colleague. We'd like our next event for developers will be on August 21st, but we also have events for designers and marketers. And just to mention, this will be our last event in this space here at Spaces. We will be moving to Workwise, so I'll be blasting that all over the emails. Don't worry. Now we have our community news section. So if you want to form a little queue here, I'm going to have folks come up, make an announcement for a minute. Maybe you've got a job opening at work. Maybe you've got a product announcement, startup ideas. Don't be shy. Come up and do your little pitch. I was going to say, for us, we are hosting an engineering workshop on the 31st of July in San Francisco. We have a pretty great discount for AIUG members. So if you use the code AIUG29, you'll get a ticket for $29. You'll have access to all sorts of hands-on training. Even if you can't make it, you will have access to the recordings afterwards. It should be a really good day. So I'll let you guys get that code. Brilliant. So yeah, everybody come up. I was going to say. Arjun, if you want to take the mic.
Thank you. Hi, everyone. My name is Arjun Saxena. I am the founder of Humanic. We are building an agentic marketing activation platform. So if you think of Marketo or MailChimp, we're building it with AI agents. So all of this information was really great. While building this company, one of the things that I encountered was that building is easy, but selling is super hard. It is so hard because there are so many people with very similar ideas, so many overlapping things that to stand out and build a viable business in this environment where it's so democratized, you can write code with, in English, is why we started a community called Code Growth, where the idea is how do you grow with code, like do marketing and growing your business. So we've done a few events in Cineed, and AI user group has been very open to us presenting, and we are doing a conference in a couple of months in San Francisco, where we are bringing in a lot of people who've built with agents in certain domains like AI for content or AI for SEO, AI for automation, activation. So anything that you want to do for growth and marketing, we bring a lot of speakers together. This is our website. It's called codegrowth.humanic.ai. There should be a QR code that should have shown up, but if you just refresh that, it will show up. Yeah. So you can go to the website, register, and I hope to see you in the conference in a couple of months. Thank you. Thanks.
And Arjun will be speaking at our next AI for Marketers.
Hi all, my name is Kamil, and because Filip had to leave, in case you have any questions about Wordware, hit me up. That's all.
Thank you so much. Anybody else? Yeah.
Hi everyone, my name is Dominic. I work at Twilio. Some of you might have heard of us for communications like SMS, voice APIs, etc. I work on our emerging tech and innovation team, so I've heard a lot about agents today. If you're interested in using agents for customer engagement, whether that is customer support, pre-sales, product co-pilots or similar things, we have a new offering that's in developer preview right now called AI Assistants. It's an agent builder that allows you to build customer-aware agents that can learn about your customer as you're engaging with them, and they're omni-channel, can perform actions sort of similar to how we've seen tools today. And yeah, if you're interested in it or you just want to chat, let me know, I'll be around.
Hey everyone, my name is Dan. I work at a small shop a couple blocks away called Fractional AI. We are a consultancy. Basically, we work with companies who see this AI stuff happening and they're a little too timid to take it on their own, and it's a really fun way. We are focusing on hiring people who are good software engineers who want to learn about this stuff and basically get paid to learn about it. So if you're interested, I'll be around. Come talk to me.
Hey, how's everyone doing? I'm Terry Demiba. I'm from Quadrant. I'm going to be hosting a webinar with Rolari on the 31st at 9 a.m. So if you can't be here in SF for their event, hop on our event, which is going to be online so you can access it anywhere. We're going to be looking at how to evaluate your models using a data-driven approach with Rolari, which is a YC Combinator company. And I'm from Quadrant, so come say hi.
Anybody else? Any last announcements? No, you don't. Come on. We had a really good social group today. Come on.
I don't know how qualified this is, but so I lived in San Francisco for 10 years. Back in the day, I actually worked at Marketo, which was mentioned. And I'm moving back to San Francisco, and I'm looking for like any sort of hacker house situations or whatever. And I'm also a founder and CEO of an automation consulting firm. It's a whopping 1-employee company. Actually, I have a subcontractor too, but if you're super into like Workato or Zapier type automation, workflow automation, and interested in doing some consulting, I'm actually, doing some work for one of the big VC firms in the area, so super cool. Hit me up.
Brilliant. That was a perfect announcement. I'm glad you made it. Great, guys. Well, thank you so much again. Thank you to our co-organizer, N8N. And thank you so much for attending. If you've had a thought about speaking or you know somebody you'd like to get in touch, there is my email and my details. Feel free to reach out or come chat to me now. Thanks so much. Hope you enjoy pizza, networking, meet lots of cool folks.